Baby blood can save you from sickle cell disease. Now, that might sound like some violent crimes are happening, but they're actually not. Just listen up. Basically, whenever humans are born, we have different blood as infants than we do as adults. As in our first 9 to 30 weeks of life, we have what's called fetal hemoglobin, which are built up of both alpha globin and gamma globin subunits. Now, fetal hemoglobin basically helps with an enhanced oxygen carrying ability, as whenever you're a fetus, you want to get as much oxygen running through your bloodstream as possible in order to help you develop. However, after that first 30 weeks of life, our blood transitions from having fetal hemoglobin to adult hemoglobin, which has a different structure, as instead of alpha globin and gamma globin subunits, adult hemoglobin has alpha globin and beta S globin subunits. Now, this is when sickle cell comes in, as the HBB gene, which is the gene that synthesizes these beta S globin subunits, is mutated, causing those beta S globin subunits to kind of compact themselves and form these sickle cell shapes. Now, sickle cell is an excruciating disease. And of course, whenever new scientific innovations come out, like for instance, CRISPR gene editing, the first FDA-approved gene therapy that scientists wanted to use CRISPR for was, of course, to treat sickle cell disease. So they came up with a gene therapy called Casgevy. And what Casgevy does is it basically targets a gene in your body called the BCL11A gene, which is a gene that's extremely important for your body switching from producing fetal hemoglobin to producing adult hemoglobin. And when Casgevy targets this gene and alters it, it basically causes your body to then produce more fetal hemoglobin again, causing those who have sickle cell disease to have normal looking red blood cells again, as those red blood cells now no longer contain the beta S subunit that causes the sickle cell disease to begin with.